Hello, this video is for the use of standard deviation in A-level biology. We're going to briefly go through what the equation looks like and the steps to use it, and then go through a couple of examples. These are all part of the PowerPoint that is in Lesson 2 of Evolution, so the variation calculations and variation graphs. Standard deviation is a tool that tells you how spread out the data is. In general, if you have a higher standard deviation, that's going to mean there's more variation in the data set that you have. And that data set could be the height of flowers, it could be the number of spots, all kinds of different things that you might measure in biology. To calculate standard deviation, all you really need is the data set. From that, you can calculate the mean, and then that's basically all that you need. Let's have a look at the equation. So standard deviation is equal to the square root of the sum of all values take away the mean squared divided by the number of terms take away 1. In some textbooks, instead of having the sign there, you'll have an S sign for standard deviation. Let's go through what the rest of the terms mean. This term here means sum of, so you just add together all the terms. The first x is the data point, or the value. The x with the line over the top of it means the mean. And then you have your n, which is the number of terms. I'm going to show you the long way of going through this equation. Once you get good at using it, you can actually do it in one go on your calculator, and that saves you the problem of rounding errors. If you're rounding the whole way through, you're going to end up with an answer that is different than the actual answer. Whereas if you do the entire calculation in one go or don't do any rounding whatsoever, then you'll get the correct answer. So steps. First step is to count how many data points there are. That was n. Then you're going to calculate the mean, which was the x with the line over top of it. You're going to subtract the mean from each data point. So that was this step. Then you're going to square that result for each one. Then you're going to add them together. Then you're going to divide that by n take away 1. And last but not least, you find the square root of the entire answer. Now again, once you get good at this, you can do it all in one go in your calculator. But until then, it's fine to go step by step just to make sure that you have it. So let's take a look at an example together. If I have a data set of 3, 4, 8, 6, 4, and 5, we can start by saying what n is. So n's the number of terms. So I literally have 1, 2, 3, 4, 5, 6. So n is equal to 6. Then I'm going to calculate the mean, which is going to be 3 plus 4 is 7, plus 8 is 15, plus 6 is 21, plus 4 is 25, plus 5 is 30, divided by 6, which is the number, gives me 5. So my mean is 5. Then I'm going to plug that into my equation. So I'm going to say the first value, so 3 take away 5 squared plus 4 take away 5 squared plus 8 take away 5 squared plus 6 take away 5 squared plus 4 take away 5 squared plus 5 take away 5 squared. So all I've done there is applied the equation of x take away the mean squared, and I've just plugged those values in. I'm going to end up with 3 take away 5 is minus 2 squared is 4, plus 4 take away 5 is minus 1 squared is 1, plus 8 take away 5 squared is 3, which is going to be 9, then 1, then 1, then 0. So my value of sum of x take away mean squared is going to be 4 plus 1 plus 9 plus 1 plus 1, which is 16. We're almost there. Let's go to the next page just to give ourselves some more room. So we had the sum of x take away mean squared is 16. I know that my standard deviation is equal to that over n minus 1 square root. We can go to my n minus 1. N was equal to 6, so n minus 1 is equal to 5. And then I can start plugging my numbers in. So this is this, and this is this. So now I can rewrite the whole thing as standard deviation is equal to the square root of 16 over 5 which will give me 1.788854,382. Let's say that they ask for it to 2 decimal places, then it's simply going to be 1.79 as I round up. So that easy. Looks complicated, but when you break it down into its component parts, it's actually pretty easy. Let's take a look at a second example. So example 2, data set is 10, 27, 39, 14, 20, and 16. Be a good idea for you to pause the video and have a go at doing it yourself. Okay, hopefully you've done that. Let's take a look. We'll start with n. N is equal to 1, 2, 3, 4, 5, 6. N is equal to 6. The mean this time is going to be 10 plus 27 plus 39 plus 14 plus 20 plus 16 divided by 6, which is going to give me 21. And then I can do my equation of x minus the mean squared, and that's going to give us 10 take away 21 squared plus 27 take away 21 squared plus that. And that is going to give us 11 squared plus 6 squared plus 18 squared, plus 7 squared put those in for the sake of completeness, plus minus 1 squared plus minus 5 squared, which is going to give us sum of x minus the mean squared is going to be 556. So again, going to another page just for room, we said that sum of x take away mean squared is 556. We said that n is 6, so n take away 1 is 5. We can then plug that into our equation. So square root of 556 divided by 5, which is going to give us 23.47. So hopefully you got the same answer as me. I've put a question on the worksheet for you to have a go at, so please use those first 2 examples as help.